Okay, so hello everyone. I'm going to demonstrate how we can use an agentic software that is similar to OpenClaw, but it's uh, it's much more limited in terms of resources usages, because as we know, OpenClaw requires a significant amount of compute, so you will require at least some gigabytes of RAM and spaces on the disk to run it and to enable it to do its jobs, whatever you tell it to do. And since OpenClaw has gained popularity, there are people that are writing some kind of alternatives. Some are claiming that they are more lightweight and can be run on a more constrained device. So I think there are some of them like PiccoClaw. So yeah. Or some of them I like NanoClaw or zclaw. And this is the one that we are going to use. Since my backgrounds are in embedded systems and mostly I'm doing IoT for the last 10 years. So we're going to try and run this agentic loop application or software inside this tiny microcontroller, except I'm going to use slightly different devices. And this is the device that I'm going to use. So this is a M5Stack CoreS3 product. Oops, sorry. It has 2 inches of TFT display and it has a touch screen that we can use to interact with the device, and actually it has a lot other features as well. So as you can see here, this is the camera and it has some kind of proximity sensors, and it has boards that we can use to communicate with other devices as well. And this one is, if I'm not mistaken, this is the GPIOs only. This is the this is the positive voltage, this is the ground, and IO port, and then this is for the UART communication, and this one for the 9-volt DC power supply, and this one is, I think it's for I2C. Okay, so and to run this application, so if we look at this zclaw source code, it doesn't actually use some kind of display. So the main interface to interact with it is using the UART interface and using Telegram. So we can chat with the IoT device by using Telegram, and we can send it instructions so it can do anything based on the available tools. We'll get there. So this is just some kind of introductory to the zclaw, and I'm going to apologize because there's going to a brief flashbang. Boom. Okay. So this is the diagram of what maybe the stack of this demonstration that I'm going to show you. First, we have Telegram to communicate with the zclaw. The zclaw, the firmware, are using Wi-Fi. So this device is connected to my local Wi-Fi, and it has tools that is specifically made for this device only, and some built-in tools provided by the original zclaw has been disabled by me for safety reasons. And this current application running on this device has to the graphics code, graphical user interface that I created from ground up. It controls IO extender because it needs more GPIOs to do things, and it has some kind of power management IC to control the power source, the battery, and so forth. And then it also has a 2-inch TFT display and touchscreen, like I said before, and it runs on the ESP32C3, and it has an 8 megabytes of external RAM. So as you can see here, it has free heap for 8 megabytes. Oh, I can get it into focus. So, and another big change that I want to introduce is that I want the zclaw to support the Azure OpenAI as the LLM provider backend, because currently zclaw only supports OpenAI, Anthropic, and OpenRouter, Olama. It doesn't support the Azure OpenAI yet, so I'm going to introduce this change, and I'm going to demonstrate that we can use Azure to communicate with the IoT device using the Azure OpenAI. Okay, so let's get to setup. So here I have my Azure portal. I'm going to create Azure OpenAI, close, and I'm going to create this one. I'm going to create. So I'm going to create a new resource group. Let's have it there. I'm going to name it as OpenAI, and I'm going to use this standard pricing, and after that I can just next. It is now currently validating the provisioning, so once everything is okay, I think I can just create. So while I'm waiting for this resource creation, I'm going to try to create the Telegram bot, because we're going to use the Telegram bot to communicate with the IoT device. So let me head to here. So we are going to use this bot first. I want to use this bot fodder to create the bot. Let's say I will create a new bot. Let's say audience of zclaw bot. Okay, create, and I'm going to copy this, but let's save it for next time. And I'm going to get my user ID so that the zclaw bot can communicate with my Telegram user. And this is the ID. This is my ID. I'm going to copy that, and I'm going to save it for later. So now let's be back to this. Okay, so deployment is succeed. Now I'm going to go to the OpenAI or Azure OpenAI portal, and now they're using the Microsoft Foundry instead of the old Azure OpenAI portal. So this is different from 2 or 3 years ago. So I'm going to create a new deployment for this, and I'm going to use a very simple model. I think I'm not going to use the powerful model like GPT-4 5.4 or even the Pro. I'm going to use the mini one because it is relatively cheap to experiment so we can just experiment without wasting too much money. or too much Azure credits on this one. Oh, okay, so it is now, I already deployed this one, so I think I have to use another model instead, which is fine. So let's create another model. Let's use GPT-5.4. Let's try again. Okay, let's use the nano instead. Or we can just 24.3. Yeah. Or 5.2. Okay, I think I'm going to try and use the GPT-4 5.3 instead. And if this doesn't work, I think I can just go back to my previous experimentation. Whatever. I'm going to add the zclaw term to the deployment name, and I'm going to select deploy. Okay, so I think the previous creation succeeded, but somehow I cannot find it in here. So I'm going to use this resource instead. So yeah, whatever. Let's try to use it. And let's see here. The URL. Okay, so this one is using this uses the response API. Yeah, let's try this. Okay, so once we have the API key, the URL endpoint, and we have the Telegram bot token and the user ID, I think we can continue provisioning the zclaw bot. Okay, now I'm going to back to my new Vim, and let's try. So the script to provision the credential is from here. Script provision.sh. Now it will connect to the USB modem, to the USB port of the IoT device, and I'm going to use my SSID. So in here, we can choose the LLM provider. So the default is OpenAI, but you can also use another provider as well. But I'm going to use Azure OpenAI, the one that I added myself. So now we'll have to use the deployment GPT 5.3 chat zclaw. This is the one that we deployed before. And I'm going to copy target URI to this. Okay. So I'm going to show my API key here, but it should be fine because I'm going to delete these resources once I'm done with the video. First, it will have to verify the connection to the API, and it succeeded apparently. So I'm going to provide the Wi-Fi password, and you know this is not the safest password ever, and I'm going to use it anyway. Now we'll have to copy the Telegram bot token here, and this one will also be visible, and it's fine. I'm going to delete it later again. And this is the chat ID. So it will try to create an image, binary image, to save the credential to the IoT device. And now if we see the camera here, it's too bright. It's okay. Okay, now I'm going to open this one. Let's say I'm going to search Owens. Wait, what was my bot name again? Owens zclaw bot. Okay. Oh, I should be searching in the contact instead of the chats. Here, Owens zclaw bot. Okay, this is the bot, and I'm going to start. Okay, so now I'm going to open in another window. As you can see here, we can now chat with the IoT devices. IoT device, I mean. And as we can see here, it has a few chat commands, and it has a USB local admin commands. And I'm going to try asking it, hello. And let's see if it works. It should take maybe a few seconds to respond. Okay. There is some failure in the API. I'm going to inspect the error. Interesting. I think let's try to use my GPT-5.4 instead of GPT-5.3. So seems the integration that I made with the Azure OpenAI API is not working very well for other model yet. So I'm going to reprovision. So I'm going to go back to this and let's see. Okay, I'm going to copy this. I think I made a mistake. Okay, let's try again. No, deployment name is GPT-5.4 zclaw. And the response API is here. The API key is here. It will try to verify again. So API pass. I'm going to give the password. I'm going to go back to the Telegram bot. Copy. And I'm going to copy this again. Okay. Let's see if there's another error again. I think there should not be error because I've changed the model. Now instead of the GPT-5.3, I'm using the GPT-5.4 mini. Okay, so let's try again. Hello. Okay. This is not the actual response, so let's wait. And now it says hello. Okay, so now the API works. So I'm going to check what are the available tools. Hey, what are available tools at your disposal? And now it has this device and status tools. There, it has memory tools, scheduling, like cron job tools, and there are a lot of custom tools. And I'm going to try and use set the display to 80%, please. It should lower the display brightness, and we should be able to see. All right, that's cool. And it's the response with done. Okay, let's try again. What's the current battery voltage and percentage? It will check the battery because I have added a tool to interact with the power management IC and the display, so that now the zclaw can interact with different kind of devices as well. Because originally the zclaw is made for ESP32C3, and it is, I believe, this one. I also have that device here, but as you can see, it does not have anything. It's just a microcontroller and some necessary modules, necessary components inside this module. But this one is more complete. It has a display and other features that I explained to you earlier. Okay, can we change this text? And of course, let's say display the current battery value, both voltage and the percentage in the main display text, and use bahasa Indonesia. Let's see, let's try. So in my opinion, it will try to use the get battery voltage and percentage tools, and it will also try to use the set display text tool. And as you can see here, and now it's speaking bahasa Indonesia. Sudah is the bahasa Indonesia for done. And battery is battery, it's the percentage, and tegangan is the voltage. And it is shown as microvolts instead of volts. Okay, so we have seen the demonstration, but I'm going to do one last demonstration. Create a schedule to check the every 30 seconds. And print every 30 seconds. Then the battery value should be displayed at the main screen display text, and you should include the current date and time. So it will try to create a cron job that runs every 30 seconds, I can schedule a 30-second interval. Okay, so sure, I think I'm going to take the agent's recommendation. Cool. So while we wait for the job to run, I think I'm going to show you the code. So let's jump to the code here. So if we compare to the zclaw source code, there is no CoreS3 folder because this is the one that I'm using. And look at that. The main display text is updated. So yeah, it's so cool. And the time zone is in UTC plus 0. So it's actually 13:15 now, but it's actually 6 in GMT plus 0 or UTC plus 0. Okay, so here I'm going to show you how we added the tools. So first, let's see here in tools definition, I'm going to search. I don't remember. So let's check the web. So there's a guide to build your own tool, and I already did that, but I forgot where. I'm using this main built-in tools. Okay, so that's where it is. Main build. Okay, so it's actually not a built-in tools because there are many tools available here. There are GPIO write, there are GPIO read, and GPIO read all. I placed them under a guard, and it's now currently disabled. And this is the one that I added. Set display text to update the main display text here. And then there's the set display brightness to update the brightness, get battery percentage, get battery voltage, and get battery brightness. And this is just macros. The actual C code that will be executed when these tools are called by the LLM is in here. Tools CoreS3. This is the code. Okay, this is one that handles the test display, set display text handler. This is the set brightness and get battery percentage, get battery voltage handler, and so forth. So these are all defined in here. And I'm going to see the code for the LLM. So I added this to check whether the LLM uses response API instead of chat API. And the one that I'm using right now is using the response API. So yeah, I added, and we added the Azure OpenAI backend enumerations, and I'm going to probably send a link to the fork of the zclaw, but you can read everything, the code that I added there. And yeah, I think that's it. That's the demo. And as you can see here, it runs every minute. Now I'm going to check how many scheduled operation that is available in my IoT device. List all schedules. And it will respond. Action, blah, blah, blah. Now I'm going to clear. Let's wait. Okay, the zclaw said sampai jumpa, which means goodbye.